Welcome to the lecture series on soft computing in computer science. In this session, we are going to discuss about a set of intelligent optimization algorithms that is not been covered under the topic genetic algorithm. This part 3 lecture is going to present a group of intelligent algorithms that has swarm intelligence as their basis. Let me introduce the algorithm and then we can discuss and further explore how to implement and how to understand that algorithm through simple hand calculation. Swarm intelligence. Swarm intelligence, the name swarm in the swarm intelligence refers to group. So here we are talking about creating or utilizing intelligence not by an individuals but by a group of individuals. That means the intelligence is collective. When you go for searching an item that you have left somewhere, if you alone search for that item, then it will be a time consuming one. In case if you are going to search the item and your friends and neighbors are also assisting you to search for the items, then your search is very easier as well as faster. Why is it so? When as an individual if you search for an item, it is a time consuming. When with others or as a team when you search for items, it is less time consuming. So what is the fundamental difference? When as an individual that intelligence is one man intelligence, when as a collect the intelligence is a group intelligence. So what is this swarm intelligence is all about? Swarm intelligence is a kind of artificial intelligence techniques based or it is inspired around the collective behavior in a decentralized or a self-organized systems. Yeah, SI, that means swarm intelligence systems are typically made up of a population of simple agents interacting locally with one another and with the environment. So when you start discussing the swarm intelligence algorithm, you should think about some population of agents. These agents interact among themselves as well as interact with the outside environment. In general, there is no centralized control structure, a structure that is not needed to say how an individual agent should behave. There is no need. Further, the local interaction between such agents often lead to the appearance of global behavior. Examples of such systems are ant colonies, bird flocking, fish schooling, and still you can keep on telling the kind of organisms or living creatures or insects or any living things that live in group. So when there is a group of individuals living together towards a goal, so those we can find this behavior. What kind of behavior? That means each and every individual in that group is having its own intelligence, but rather utilizing their own personal intelligence, it is also trying to use the collective intelligence in order to fulfill the objective criteria. So these are all the kind of examples we can see in the nature there we can find swarm intelligence. This swarm intelligence requires a lot of flexibility. Say for example, if we place a bunch of flies in a jar, lay the jar so its bottom is facing on open window, then open the lid. Flies will bump and around randomly, then fly out the lid, find the open window and leave. Bees will continually try to go out the bottom and he will eventually die. So it means that based on the intelligence collected by the neighboring bees or neighboring insects, it will try to go up, and it means that in the upward space only here. Suppose if you randomly down lid side, so what is that? It will also try to go out of the bottom and finally it will try to die. So this is the flexibility that is prevalent in swarm intelligence. So using this swarm intelligence, an algorithm has been developed by James Kennedy and Russell Eberhardt, and this algorithm is named as particle swarm optimization, and it is based on the imitation of the motion of flock of birds. How a group of birds is flying together, what type of social and individual cognitive behavior is associated with this group of birds. All these are thought process of developing this algorithm. So what is PSO? PSO is a stochastic robust optimization technique based on the movement and the intelligence of swarms. PSO applies the concept of social interaction to problem solving. It uses a number of agents that constitute a swarm moving around in the search space looking for the best solutions. Each particle is treated as a point in n-dimensional space which adjusts its flying according to its own flying experience as well as the flying experience of other particles. So, when you give a space, the particles move in random, but the particles will try to always acquire the experience of the other particles. So, that is the wonderful behavior of the group of particles that are living in together in nature. There are some terminologies associated with PSO. What are those terminologies? The first one is population, second particle, third evaluation, fourth fitness, and fifth one is population manager. To begin with this PSO algorithm, every algorithm starts with initialization of the candidate solutions, and these candidate solutions consists of m particles and they are set as populations. Recall genetic algorithm. Here in genetic algorithm, population is set of chromosomes. Likewise here you are going to generate randomly set of particles. What a particle represent? A particle represents a candidate. It is one of the solution to the problem that is have been taken. Say for example, again I am taking to the point, you have missed a jewel or bangle somewhere in the place, and you have going as a single person to search for the bangles. It may be somewhere else, but it will take some more time. Suppose if you are calling your friends, to look for this, now these 3 persons are also trying to search for. Now the effort is among 4 individuals. So each individual can find the place in which the article has left. So it is a candidate solution. Each one is treated as a candidate solution, and each candidate solution in the PSO terminology is characterized by a velocity vector, fast or speed, or the strategy in which it is each person is applying to find out the stolen or to find out the left out ornaments. So each is associated with the velocity v and a position vector x. Remember there are 2, v and x. This v is nothing but velocity and x is nothing but position given the dimension d. Now what is the evaluation span? Evaluation span is nothing but up to what period each candidate is evaluated and the evaluated candidate is retained its originality in the timestamp, the given timestamp, that is the evaluation span. For each evaluation span, the fitness function is evaluated by an individual or by a candidate giving the solution, and this solution is conveying the effectiveness and the efficiency of the its own candidate. And finally the population manager. So the population manager roles is to, once the entire set of the dimension has been fulfilled, d value is fulfilled, the next phase is to update the velocity and the position for each particle as a loop process, and the process of evaluation and the fitness function thing is repeatedly carried out until you get the convergence, like in GA. I wish to recall the fundamental approaches that has been followed in genetic algorithm, that is initialization of set of population followed by evaluation of the fitness function, selection of the best individuals, like that applying the genetic operations, like that here population, particle, evaluation span, a fitness function, population manager. Each principles that means the fundamental principle of PSO is evaluate and compare and imitate. First evaluate its own position. Now I am searching for the stolen article or left out article. So my position is evaluated first, and then its position is compared with the my previous best position as well as the neighborhood best position, because it is a collective effort, right. So this is comparison. And the third one is imitation. By means of self, by means of others, some imitation is carried out. So this is what the general principles of PSO algorithm: evaluation, comparison and imitation. And here you should remember two terminologies. One is P best, another one is G best. What is P best? I am searching for the optimal one, and whichever the position that I feel as my best position, that is treated as a P best, and whichever the position that is treated while searching for the optimal solution, whichever the position is treated as the overall best position, it is treated as the G best. These two are most important: P best and individual's best, overall best. In short, we can say that. So the basic concept of PSO lies in accelerating each particle towards its B best as well as the global best. So that is the main, but with a random weighted acceleration. So this is the fundamental principle. See, if you could see that, see here he is a big particle, here is a particle. So this particle is moving towards its best performance or moving towards the best performance of its best informant, that means overall the group who is leading the best position, or towards an accessible point by following its proper velocity. So there are three alternatives it can take. See, I can take based on my own personal velocity, that is my personal effort, that is my personal, it may be a best at one point in time. If it is not best, I cannot follow that best, not best value, but I will need to backtrack myself and go towards the best. While going towards the best, if I was informed that the overall best value, then I can go to that direction also. So this is what the vector. Say for example, this is 0.5. Let us take this one variable x1 and this x1 variable is 0.5. Now this 0.5 has a steady velocity that it gets increased to 0.7. So let us take an example, but it keeps remember that its previous best value is 0.9. and also it sees that its overall best value is 1.1. So now it is the decision of the individual to take which position it has to take. Its own position of iterative process, it will go to 0.7. So 0.7 is best or 0.9 is best or 1.1 is best. Accordingly the entire algorithm keeps working towards which best one the individual has to choose. So the framework of the PSO particle is, so each particle consists of three vector. One is the x vector, and the x vector records the current position, and another one is the p vector, and this p vector always records the best position so far by the individual, and the v vector is nothing but its own velocity, Now and you have to calculate two fitness value. One is x fitness value, that current position it has to be subjected to fitness evaluation and its fitness value, and the overall best fitness value, it is also essential to keep track whether we are going in the right direction or whether we are going in the worst direction, and we have to redo the direction change according to the b bedness x and p bedness value. So there is a comparison between these two at always time. Likewise here, see, it is going 0.7 and it is attempting to go to that position, but it keeps remembers that its previous best position is 0.9. Now here there is a comparison between 0.7 and 0.9, since it is a kind of problem that suits the optimization with 0.9 only as the best value, means then instead of going to 0.7 it always choose 0.9. So this is the comparison between the x fitness value and p fitness value. So this is the fundamental principle or the framework that is prevailing in the PSO algorithm. Swamp search, how the search is conducted. In PSO, particles never die, whereas in genetic algorithm you can say that survival of the fittest principle is applied, and some chromosomes are not brought to the subsequent generation. It is said that the chromosome is no more because of the survival of the fittest. Only the elite, only the best individual are keep tagging in the next individual. But here particles can be seen as simple agents that fly through the search space and record. Maybe it communicate with neighborhood also. So the best solutions that they discover. So every time these particles is acted as a agent and it is flowing towards the position that it can record and it also recover. So the question here is, how does a particle move from one location to another location? How? If it is keep on doing like these things, how a particle from one position can move to another location? That is a fundamental question. So for which they are provided with the equation that means xi equal to xi plus vi. What is this xi? Here this I, there this I varies. That means xi plus 1 that is equal to xi plus vi. Vi plus 1, we may treat that. That means new position is equal to old position plus velocity. So according to the velocity, it has been changing. So for each and every new explored position, its x fitness value and p fitness values are calculated. So in this way swarm search is happening, and the velocity is also keep changed. The new velocity is equal to old velocity plus some formula. I will come to that formula. What is there? What is C1 and what is random? What is this value and what is this value? So while the particle is in the search process, the position only not changed, but also the velocity is also changed, and the change in velocity is calculated by new velocity is equal to old velocity by these factors. Here this C1 and C2 is changed as cognition and social components, and the G represents the global witness and P represents the individual witness. So that is the idea. That way the PSOs. Swarm types. Initially when you start executing this BSO algorithm, the values of the velocity vectors are randomly generated. It may be within the range minus V max to any range. The inventor of this algorithm, Kennedy Eberhard, he has identified 4 types of PSO based on what are those? Full model, cognizant only, social only and selfless. There are 4 models. All these based on C1 and C2. If you check the value of C1 and C2, if both C1 and C2 are greater than 0, then it is a full model PSO. If C1 is greater than 0 but C2 is 0, then it is a cognizant only C2. The social only, C1 is equal to 0, C2 is greater than 0. Selfless, C1 is equal to 0, C2 is greater than 0 but G is not equal to that ratio. So accordingly the equations are validated, updated and verified. So this is the fundamental types of PSO swarm. How the velocities are controlled, exploding kind of velocities may happen. So when using PSO, we have to check with the magnitude of the velocity. That means the velocity may go very large. If the velocity may go very large, automatically we can seek a suffering in the performance. In order to control the explosion of the velocity, explosion of the particle due to the high velocity, we can have something else called a inertia factor, and it has to be dynamically adjusted over the period of time. And also you have another factor called constricted factor. These two are the variables that act as a controlling measure of too much increase or too much level of growth of velocity. So the inertia factors, what is that inertia factor? So when the inertia factor is used, the equation for updating velocity is changed to see W into VID. A large inertial weight will facilitate a global search and a small vision. So now what is that? Exploration and exploitation has a balance. If it is large value, when the W is large value, global search is very effective When the W is treated as a small one, then the local search is very big. So it means that you should linearly decrease the inertia weight value from the large value to a small value during the course of PSO run. If that is the case, then PSO gives the best performance, right. So this is the thing that you should remember. So here in this equation, one more factor is introduced, that is W. Other things are common. Constriction factor. So what is this constriction factor? This is C1 C2 are constriction factor, and if you add this constriction factor, and this constriction factor should be greater than 4, and this is the way in which you can check the constriction factor K. So this is another way of checking the velocity updation, and Marie Clark in 1999 have introduced this constriction factor parameter. So in general, what is an algorithm? What is the PSO algorithm? Like genetic algorithm, it also sorts with the initialization of population, but here the population is referred to as particle, and the particle is nothing but consisting of two vector. One is the vector of random position, another one is vector of random velocities. Now with the help of position, each particle fitness is evaluated, and then based on that evaluation its own P best is calculated and the overall global best is calculated, and based on the P best and C best value some comparison is happened, and then the velocity and the position updation has been happened. So first one initialization, here evaluation, here comparison, third one this is P best to its own previous P best, and this is another comparison, this is the individual best with the global best value, this is the updation, and finally loop. Up to what level we can go with. So generally the up from second steps to fifth step 2 to 5 are iterative steps. So this is what the basic PSO algorithm. So it is represented in the flow chart. To start with, we need to define the solution space, we need to know our solution boundary as well as the problem statement. Based on the solution boundary and problem statement, we are generating the initial population, as well as initial population means it is a vector consisting of positions and velocity, two vectors, and each particle position is evaluated through the or with the help of the objective function or the problem statement, and its global best as GVL best is updated, and you have to check the stopping criteria. If yes, then you have to end the process by taking the decision, otherwise you should update personal as well as G best according to the business. So this one updation, another one, this is one updation, and these updations are most important updations. This is updation of velocity at the position, that is updation of just when it is a new position has been gone up, when it is a new global best has been updated like that. So this is the fundamental idea to go out with particle swarm optimization. So once again I start summarizing what is particle swarm optimization. So what is particle swarm optimization? Simply a particle swarm optimization is an algorithm for solving optimization problem. Who has developed? Russell Eberhard and James Kennedy in 1995, they have developed this algorithm. What is the inspiration? It's birds foraging behavior, because in early morning you could see that the birds are flying together as a group. You may wonder why these birds are flying, that means the birds are flying to search for their food. So that searching for the food is nothing but foraging behavior. So what is the inspiration of PSO? Now each bird is treated, each bird searching for food and their social interaction. A bird is treated as a particle which has two vectors, one is position vector and another one is velocity vector, and searching is nothing but evaluation of the position. Searching is nothing but evaluation. What is the food here? Solution is the food here. So this is the food searching behavior, and P best is each individual, this bird has its own best food value, this bird has its, and overall there we will have a best food value. So that is the B best and G best, and this is social interaction. So a group of bird is going on the way to search for a food, they have individual intelligence as well as collective intelligence through interaction, through collective interaction. So updation has been happened and we are obtaining the best fitness value. So, the social interaction of bird, how the social interaction of bird is happening. See, look at this, there is a bird in the group of bird, each individual it's this bird is 100, this bird is 80, this bird. So, now this individual bird is remembering its position. Originally it got 100, over the flying it got 80 and 50. Now it's since it remembers its past knowledge, what position it will take? It will take to this 100. So, this is its individual cognitive behavior. And another one, social behavior. Now what is the social behavior? Look at, now this bird one is saying that I am finding a food position where I can, where the food quantity is 150, my food quantity is 100, my food quantity is 100, my food quantity is 400. Now this bird, even though its individual fitness value may be 120, now what position it will take? It will take to the global food position towards the bird. So that is why when you see the bird's group flying behavior, all of a sudden the direction changes. It means that there is a bird that finds the best location and best direction. So all birds keep searching or keep following that bird which has the best fitness value, right. So based on this behavior, two equations have been introduced. New velocity is equal to weight into old velocity plus C1 into random PID XID, C2 into random PIGD XID, and the new position is equal to old position plus velocity. So this is the two fundamental equation that you should use for. So again the flow chart is in the same way. See here, updation is happening here, this one updation, and here this one updation, and for each particle the position is evaluated the fitness value. Finally you are giving out the G best as well as the optimal solution. So this is the yet another way of understanding the implementation of the PSO through a flow chart. So you are starting with the initialization of particle, and for each particle this evaluation is carried out. So to understand further and to have a comparison with the genetic algorithm and how this PSO is performing, we will take a case study. See the same function that what we have discussed under genetic algorithm, this is the function that has been taken here for understanding the PSO also, and the range is this. Now what we should do? We should initialize two vectors, one vector is position vector, another one vector is velocity vector. See, this is the position vector, this is another vector. So how much population that I have created? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So 15 for each. So that means 15 birds, and each bird's position is measured by xy and its velocity. Now its fitness value is evaluated for the given objective function. While evaluating the fitness function, I could observe that this is the best value. Which position is giving the best value? So the birds are flying, and each bird is 15 birds are flying, and each bird is having its own xy value, and the bird which is having, what is the bird? The 13th bird, the 13th bird which has the position value 2.6954 comma 1.986 has find out the maximum food value of 0.2390 when compared with other birds. So that is the fitness. Now what we have to do? We have to generate the new velocity according to the formula that is provided, as well as the new position. Now after generating the new velocity and the new position, now we find out this new position, and this is hold out by 1, 2, 3, 4, fourth bird. Now the fourth, originally the 13th bird is having, so now all the birds are started flying towards the 13th bird. Now suddenly the fourth bird, based on the new position of this fourth bird or based on the velocity updation of the fourth bird, so it has find out the new food position, and now all the other birds are flying towards the new food position value. So this is the fitness value originally, and this is the fitness value after the velocity and updation values. So like this you have to record for all the generations, and if you could say that, so the average fitness value as well as the best fitness value is keep on increasing. So this entire process, if you check with 50 iterations, the fitness value that is around 0.21 is keep on increasing. See, in the beginning generation there is a steady increase, but over the certain period of time there is no increase, and the fitness value get stable, and this marks the convergence of the algorithm. That means that even after that, if you update the position and velocity, there is no more good position of the foot value can be find out, and this is the signal where you can stop the PSO algorithm to say about the best fitness value as well as the G best value. So with this we have discussed the particle swarm algorithm and yet another algorithm, and it is basically based on swarm intelligence. This is similar to genetic algorithm, where the genetic algorithm is based on the principles of survival of the fittest and Darwin's evolutionary theory. So it is falls under the evolutionary intelligence, and this is whatever the living creatures that are living in group, it has its own intelligence, that is swarm intelligence. Both intelligence are meant for doing the optimizations in a better way, but both has its own way of undertaking the problem, its own way of principles and behaviors. So thank you.